Hello and welcome to this video where we're going to talk about exponential functions. The learning target for this video is identify and write exponential functions from tables. So first, let me explain what the general form of an exponential function is, and then I want to try to explain sort of how it's different than other forms of functions. So we're going to define it as y equals a times b to the x. And then we have a couple of rules here. So the first one is a cannot equal 0, because if a equals 0, the whole thing is 0, and then that's just kind of lame and boring. So we don't have anything fancy there. So a can be anything, but it can't be 0, or except for 0. Now b has a couple other restrictions on it. B is going to be something that is greater than 0, and b cannot equal 1. All right, because if b equals 1, then you're just doing 1 raised to a power, and that's just always going to be 1. And again, that's boring. That's not really exponential. Now, let me talk to you about sort of the difference between exponential and maybe something like linear. So for that, let's get a new color. And so let's say, we're going to do that there. All right, let's say that like you have a piggy bank, and each week you're going to add that much money to your piggy bank, whatever that is. So first week, you add this much in. Second week, you add that in again. Third week, add it in again. Fourth week, add it in again, and again, and again, and again, and again. And so you can think of that as like, adding in like a $1 bill, $5 bill, 10, 20, whatever it is. But this is linear. Each time, you're just plussing this to your overall amount. Now, let's talk about what exponential is. So exponential, we'll still start off with putting this much money in, but let's say that you're going to double it. So the first week you start with that, then you match that, but then the week after that you're going to put in what is this length right here. And then that next week you're going to match this length, so it's going to be something like that. And then the next one's going to be off my screen. It's going to be so big. So hopefully that makes a little bit of sense of what's kind of going on here with exponential, is that things are growing much, much faster. And notice how, new color. Notice how none of these are the same length. Each one is different, whereas all of these happen to be the same length. So this one is linear because you're just constantly adding the same thing over and over again. Whereas this one would be considered exponential because what's being added, or the overall value, is not really being added, but more being multiplied. It's growing much faster. So let's look at some examples and see what we can do. So our goal here is to be able to look at a table and identify what's happening. Do we have exponential growth or do we have linear growth? All right, and so new color. Let's go purple here. And so the question is this linear or exponential? All right. So first thing we want to do is we're always going to want to start on the x side and just kind of see what we got going on here. And so what I'm seeing is just sort of how we go from one x to the next x is we're just always adding 1. So every time we're adding 1. Now I go to the y and I just want to start seeing if there's a pattern that emerges. And so I'm going to start down here, and what I'm noticing to go from 5 to 8 is that I have to add 3. And to go from 2 to 5, I'm also adding 3. And essentially, now that I see it, and I've kind of started it, every time to go from one y to the next y, I'm adding 3. Now notice, adding 3. That is just like doing this one right here. I'm adding the same thing over and over again. So this one would be considered linear. Now let's look at the next one. A little more complicated, but I think it'll kind of help us. We can still, we'll figure it out. So same thing here. I'm adding 1 with all my x values. That's cool. All right. Now what I want to do is, again, pick the numbers. And man, these fractions, they look kind of tricky. So I'm going to avoid those for the moment. And I'm going to look at the smaller numbers and see what I can do. So I could go here and I could say, well, we could go plus 4, but plus 4 doesn't work there. So let me backtrack a little bit, and what I'm noticing is that maybe instead of saying plus 4, I could look at the relationship between these and say it's actually times 3. And so you either want to be looking for like an addition, subtraction, or you want to be thinking about multiplication or division. And so since there's not a constant thing I can add, I want to think, is there something I can constantly multiply by? And in this case, there is. I times by 3. And then if I kind of look at my fractions here, if I take 2/3 and I times it by 3, guess what I get? 2. If I take 2/9 and I times it by 3, what will I get? 2/3. And so since this is all multiplication, I don't like how I covered all that up. Since that's all multiplication, that means that this one's going to be exponential. Let's take a look at the next one. All right, so here, noticing that I'm just adding 1. All right, easy enough, so that's cool. Always start with x. Now, to go from here, again, if I want to, I could be like, well, I'm adding 6, but then adding 6 is definitely not going to work for this. And so start thinking like, what can I multiply each one of these by? And then this is just like the other one where I'm going to times everything by 3. And since this is consistent throughout the whole thing. Now, one thing I might do to kind of trick you in class is to maybe make this like an 82 and be like, ha, I got you. It's not exponential. It's none of the above. It's just a random set of points. So make sure you are going through, the whole table to make sure it actually does work out. And so since we're adding on the x side and we're multiplying on the right, that's got to be exponential. All right, let's take a look at this one. So here, let's see here. I'm going plus 1, plus 1, plus 1. All right, that's cool. Now here, maybe we could say plus 5, or I could even say times 2. But then if I go from 10 to 15, the plus 5, that's the one that definitely works out there. And so in that case, this one's going to be linear since it's all addition. So linear. All right, and finally, let's look at this one. Now this one's a little bit different. I wanted to show you a different look. And the point is, it doesn't matter sort of where the x or the y values start. It's the analyzing the relationship between the x and y that really matters. And so for example, here, I'm adding 2. Okay, that's cool. Nothing wrong with that at all. But again, what I want to see is like what's happening here. So I can maybe argue that I am subtracting 4, but then if I try to subtract, they're subtracting 8. Notice how that doesn't match up. That's an indicator that perhaps I need to do multiplication or division. And so here I'm dividing by 2. And then if I look at this one, I'm also dividing by 2. And then if I go to that one, it's kind of obvious now I'm dividing by 2. Now, what we might want to do later on is think of this more as timesing by 1/2 instead of dividing by 2, but that's for later on. But the main thing is when we're looking at x and y tables, we want to check to see what's happening in that y column. Is there a constant thing that we're either adding or subtracting, or is there something that we're constantly multiplying or dividing? Linear boils down to adding or subtracting, whereas exponential is when we're multiplying or dividing by something. Okay, so now we've identified, let's work on that final piece, which is writing. All right, and so let's see here. I wanted to borrow a new color. Let's go back to green. I want to borrow this guy right here. All right, so we know that this one is exponential. Now what I want to do is I want to write the y equals a times b to the x. All right, and figure out what a and b have to be. Now, here's the thing. In order to figure out what a is, we want x equals 0, okay? Because that's going to help us out a ton. And so I'm going to borrow, let me go to a highlighter. Yeah, highlighter. I want this point right here. That's key. I need that in order to figure out what a is, and I'll show you why. So back to this. I know that, so my y value is 3. And that is equal to a times my b to the 0. Now here's the cool thing. Anything to the 0 power is 1. So that just disappears. And now what happened is I know what a is. A has to equal 3. All right, so now that I know that a is equal to 3, I can go y equals 3 times b to the x. And I can pick any other point I want, and I can figure out what b has to be. So back to my highlighter. Let's just choose this guy for funsies. So 227. So pen, 27 is equal to 3 times b squared. Divide by 3, divide by 3. I have 9 is equal to b squared, and so b must be 3. So bringing it all together now, I know that my equation, the final answer for all this, is going to be y equals 3 for this a times 3 to the x, because my b was 3. All right. I'd like to do one more example, just again to kind of show you how this all works. So first of all, let me take this guy, move it up here, maybe shrink it, put him right in there. All right, so it belongs there. All right, now let me clean up this a little bit. Patience, sorry. Okay, so back to this. Let's now go with brown. All right, so y equals a times b to the x. We need that part. And now let me say that let's say our table is this. So xy, and we are going from -1, 0, 1, 2. We have 1/8. Oh no, not 1/8. 1/4. 1/2. It's 1/2. 1 is 1 and 2 is 2. Let me clean this up really quick there. All right, so y, and then that is 1/2. All right, that's a little bit better, I think. No, it's not. Let's try that one more time. 1/2, 1, and then 2. All right, there we go. So again, it all starts at this one, when x equals 0. All right, and so I'm going to put in 1/2 for y. That is equal to a times my b to the 0th power. And again, that's just 1. So now I've discovered that a is equal to 1/2. Now I can use any other point I want. So maybe I'll take this 2, 2. So I have 2 is equal to 1/2 times b squared. Now I got to solve for b. What I'm going to need to do is I'm going to need to times both sides by 2. And I'm doing that so that way I cancel out the 1/2 there. And I get 4 equals b squared. And therefore b must equal 2. And when I bring it all together, y equals 1/2 a times 2, oops, not to the squared, to the x. And there's my exponential function. And so hopefully by watching this video, we have sort of a good sort of feel for exponential functions and how they work. So again, the general form is y equals a times b to the x, where a cannot be 0, b has to be greater than 0, and it cannot equal 1. We talked about the difference between linear and exponential, what that means for when we look at the table. And finally, how we really need to zone in. If we ever want to write something that is exponential, we have to zone in at this point right here, and that will help us determine the exponential function. So good luck on your homework or practice, and let me know if you have any questions.